I'm going to limit myself to somewhat, somewhat technical issue, although there are no technical issues really in proliferation. But I believe that any sound policy in proliferation has to be based on the facts, on the pragmatic measures which can be implemented in order to make proliferation at least more difficult. I will limit myself really to the issue of proliferation and try to argue that, proliferation on the basis of present development of nuclear industry and nuclear science can be broken. Let me first show you some of the data or information about the present situation in the field of energy. First, climatologists demand very large reduction of carbon emissions, about 80% in the next 50 years, in order to keep the global temperature below 2 degrees centigrade. Most energy analysts find that such replacement of conventional sources cannot be done in this period, at least by renewable energy sources alone. So I'm not arguing for nuclear energy or for renewables. I believe that in the future energy we will have, for a foreseeable time of at least 50 years, we will have a mix of both renewable and nuclear energy. When we look at the demands which are given by climatologists for the next 50 years, then we have to see that then we looking at the situation and development, then we see that nuclear fusion will not be available in that time. And we also have to conclude that carbon capture and storage will also not be available in any large scale. You know, there are of course experiments today with the carbon capture storage on the level of, say, 1 million tons or so per year. But you have to scale it up to 1 billion tons, billions of tons per year by, say, 2050 or so. This is impossible to really accept as a realistic scenario. What can be said now for the nuclear energy pros and cons? Nuclear energy certainly offers a way for mitigation of has a operating experience for about 50 years or more, is producing 15% of the world electricity and can be considered as an existing way of reducing carbon emission. That means nuclear power stations are operating. There is about 430 nuclear reactors operating now. They are proven. They have been running for more than 50 years, and they can be, and nuclear energy can be expanded. Now, nuclear reactors in present operation require enriched uranium for their operation. Reprocessing of nuclear fuel in order to extract plutonium would be necessary to go into the breeder reactors, which breeder reactors, of course, would then remove total limitation of the nuclear resources. Now, both enrichment and reprocessing of spent fuel have been for many years already recognized. International fuel cycle evaluation study 78, 80, I think, many long time ago, recognized as proliferation sensitive. They were indeed used to acquire nuclear weapons and widen the circle of nuclear weapon countries beyond the initial 5 recognized as such NPT. So that These countries are India, Pakistan, North Korea, Israel, and South Africa. South Africa, of course, has abandoned the nuclear program and nuclear weapons, so it's really not a nuclear weapon country now. Stretch my neck. Recent developments in the field of nuclear energy indicate that the connection between peaceful use of nuclear energy and proliferation can be broken, and that political understanding for acceptance of required measure is developed. Internationalization of all enrichment installations would resolve the part of the problem. Growing danger of nuclear terrorism may induce leading nuclear weapon countries demanding inspection of enrichment installation in non-nuclear weapon countries to accept international control of their own installation. Before that, establishment of nuclear fuel engines, I then mentioned that the Reserve Fuel Bank was proposed by International Atomic Agency in 2006. These nuclear fuel engines would have to supply nuclear fuel for peaceful use of nuclear to any country without political bias and correct cost, with only requirement on recipient country to accept international atomic agency controls and inspection. That would discourage construction of national enrichment installation. Construction of national enrichment installation is very expensive, and should such a unbiased supply of nuclear fuel be available, that will certainly discourage many of attempts to develop, say, national installation. Now, as I mentioned, the proposal was given in that direction in 2006 by International Atomic Agency. Also, El Baradei was speaking about that, was Secretary General of the Atomic Energy. And we might say, wonder why the progress is as slow as it is, and possibly say, we should recommend some speeding up. The second point about, say, reprocessing is based, so these first points is more or less a rearticulation of that process which was in the air and it was going on. Second point on the reprocessing is the result of this research which we have been doing at the University of Zagreb at the reactor physics and nuclear energy group at the Faculty of Electrical Engineering and Computing. We have been looking into the contribution which could be given by nuclear energy to carbon emission reduction based on the conventional reactors and the existing resources of uranium. That means resources of uranium as estimated in the year 2007 that is given in the so-called Red Book by the Uranium Institute, and these resources have been given at 16 million tons and something over that in 2007. Assuming that all uranium would be consumed in that period until 2065, before carbon capture and fusion may be developed, we came to the conclusion that using conventional reactor technology and without reprocessing, we could develop nuclear power to maximum of 3,000 gigawatts. And the contribution to the carbon emission reduction would be about over 30%, 37% of that what would be needed to come down from the business as usual strategy to the strategy which would keep carbon concentration to about 450 parts per million and global mean temperature increase below 2 degrees. So our conclusion is that we can wait with reprocessing until at least until 2065, It means no need to introduce breeders with all the problems which will be introduced by using plutonium on many places. Because if you develop, say, nuclear power to 3,000 gigawatts, that is not going to be in the present number of countries. It's going to be much larger number of countries. So in many of these reactors, the separation of spent fuel would have to be done, and plutonium would be all over the world. So that would be very undesirable future. However, we show that it is not necessary until 2065. By that time, international institution and control measures could be developed and should be developed to use for safe use of plutonium if it is necessary. It might not be necessary even after 2065 because many unconventional uranium resources will appear by then. Also, there are informations from the American Chemical Society and by also Japanese researchers that uranium from the sea will be is available now at about $135 per pound. That means it should be certainly lower by 2065. So that means these would be the price acceptable in a conventional reactor. So we might not need nuclear breeders, fast breeders at all. Last point is just something which comes out from the experience of Fukushima. In Fukushima, we have seen that, say, although that is a country which has a highly developed nuclear technology, yet, and of course the regulation is very high, yet the company, the owner of these particular, say, nuclear plants have been cutting, say, on the safety in order to reduce the cost. That is obvious now. So it is, say, in the air. I think there is also some other experts who are thinking the same, that this should be a matter for international law. You cannot build in your own country any kind of installation that is going to be danger to your neighboring country. So some thinking in this direction should be necessary, and of course, when this is the summary of that what I was saying. When I'm asking for your understanding and support, then of course I'm not asking you to. I mean, this is a very distinguished company, but this is not an expert company in nuclear science and in nuclear energy. So when I ask you to support for these measures, which I believe should make the proliferation much more difficult, then I'm asking you to induce discussion in the bodies which are capable of, for example, international agency. Maybe some expert groups could be formed in the European Leadership Network, and also there are, of course, also in VAS, and I also believe that Pagvash could contribute. For example, say, one of the leading Pagvash, John Holden, advisor to the president, has been very active in the American National Academy of Science on various energy studies, and that is the sort of support which I think this group can do. And I'm asking for that sort of support to consider these measures for the reduction of nuclear proliferation. Thank you.